Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing about p-value and significance level. In this video, I am going to discuss about chi-square test. Let's start. This is a nice quote from Nikola Tesla. Of all things, I liked books best. Let's continue with the chi-square test. First of all, we need to understand what is hypothesis testing. A statistical hypothesis is an assumption about a population parameter. Hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. Very important. Using experimental data. Hypothesis testing is basically an assumption that we make about the population parameter. Fine. See, we already have videos in the playlist related to hypothesis testing, null hypothesis, alternate hypothesis. So you can watch if you want more clarity. Even though it's fine, I am, giving idea about those aspects as well. Null hypothesis, it's denoted by H0. Null hypothesis is denoted by H suffix 0. Null hypothesis is a statistical hypothesis that assumes that the observation is due to a chance factor. Very important. Alternative hypothesis denoted by H suffix 1. Or sometimes we may denote it as H suffix A as well. The alternative hypothesis shows that the observation are the result of real effect, that's from the experiments, not due to a chance factor. That is alternative hypothesis. This is important to discuss about chi-square test. This table, this is a very nice table. You can understand this table. When we do bivariant analysis, when bivariant analysis means two variables will come into picture. You have univariant analysis, bivariant analysis, and multivariant analysis. These are all coming under exploratory data analysis, EDA. When we talk about bivariant analysis, there is two variables. Variables are of two types, numerical and categorical. When the two variables are, that is numerical and numerical, you will use correlation coefficient. If it is categorical and categorical, you should go for chi-square test. Very important. This is what we need to understand. When it is numerical and categorical, you will go for t-test, z-test, ANOVA. These are all the important. This table is really very important. So our chi-square test, you understood when the two variables are categorical, you will go for chi-square statistics. So what is chi-square statistics? The chi-square statistics is commonly used for testing relationships between categorical variables. I already told you. The null hypothesis of the chi-square test is that no relationship exists on the categorical variables in the population. That is the null hypothesis of the chi-square statistics. Let's discuss a practical example to find out the relationship between the educational qualification and marital status. So this is the observed values. This is the observed values for the educational qualification and the marital status. So the data is given here. It is never married, married, divorced, widowed, and the total is also there. In the column wise we have the total, and the row wise also we have the total, and the grand total is also available here. This is the total in the row wise, it's there. So the grand total is given here. So this is the observed values. Now here, what is the null hypothesis and alternate hypothesis? The null hypothesis is there is no relationship between the marital status and the educational qualification. You understood. And alternate hypothesis, we are coming up with the alternate hypothesis. There is a significant relation between marital status and educational qualification. Done. You got it. Now, what is this significance level? We have a separate video under the playlist statistics and feature engineering related to significance level. If you want more clarity on significance level, you can watch that video. Here I am just giving an idea about significance level. It is denoted by the Greek letter alpha. The significance level is the probability of rejecting the null hypothesis when it is true. Very important. When it is true, you are rejecting it. What is that probability? That is significance level. For example, a significance level of 0.05 indicates that 5% of risk of conducting that a difference, sorry, 5% of risk of concluding that a difference exists when there is no actual difference. You got the point. Lower significance level indicates that you require stronger evidence before you will reject the null hypothesis. The most common significance level is 0.05 or 5%. This is very important. The most common significance level is 0.05 or 5%, which means that there is a 5% probability that the test will suffer a type 1 error by rejecting the true null hypothesis. So you understood what is significance level, and the most common value of this significance level is 0.05 or 5%. These two aspects, it's very important. Next one, next thing you need to understand is here what is expected value. See, we have in this table you have the observed values. Now for calculating chi-square we need observed values and expected values. Now we are going to calculate the expected values. In statistics, this is the formula for expected value, that is the row total into column total divided by grand total. You have the row total into column total divided by grand total. All these values we have the row total, we have the column total, and we have the grand total as well. So how we will come up with this expected values? See, I will show you the table here. This is the first value, this is the observed value. Qualification, it is never married, sorry, marital status it is never married, and the qualification is middle school. This is the for that data we have the value 18. So that is the observed value. So what is the expected value for that? For that we need to take the, what is the row total? Here the row total is 90. In this row it is 90. And what is the column total? It is 39. What is the grand total? It is 300. So to get this value here in our table, in the expected value, you need to do 90 into 39 divided by grand total 300. You got it. This is the formula. I will show you the formula. Row total, here the row total is 90 and the column total it is 39. Grand total it is 300. So we will calculate this 90 into 39 divided by 300 and you will get this value. It is 11.7. When you calculate this value, you will get the value 11.7. Again, to get the value, corresponding value for this 36, how do we do? Again the row total, that is again it is 90. What is the column total? Here it is, again it is column total, it is 90 divided by the grand total, it is 300. This we will calculate. Then you will get the corresponding value, that is 27. Like this, you can calculate all the values corresponding to the previous table, that is the observed value. Here we calculate the expected value. This is the formula for the expected value in statistics. So we calculate the expected values. See, we need to calculate the chi-square, we need the observed values and expected values. That's why we are calculating the expected values as well. Now, the mathematics of chi-square test, that is this is a Greek letter chi. So chi-square is equal to sigma summation of O minus E the whole square, the whole divided by E. Here O is the, as written, it is the observed value. E is the expected value. We have all the values, observed values we calculated from the table, observed table, and the expected values also we got it from this table. This table you got the expected values as well. So we have all the values, observed, and when you take the summation, you will get the chi-square. So this is the math of chi-square, a summation of observed value minus expected value, the whole square divided by expected value. This is the mathematical statistical formula for chi-square. Fine. Now the calculation of chi-square. Again, we need to calculate the observed value, expected value for all the data in the first table. See here, you have in the first table, you have, 18 here. See, this is our, observed value. See, for 18, what is the corresponding expected value? We have, it is, 11.7 we calculated. So we will write all the observed values. The observed values are, it is 18, 36, 21, 9, 6, 12, 36, 45, 36, 21. All these are all observed values. See, we are coming up with in the table. See, this is the calculation of chi-square, the observed values, you got it. 18, it's there. 36, it's there. 21, 9, 6, 12, like that I can write. It's a lot of values are here. You can, you can see in the table. This is C, 18, 36, 21, 9, 6. This total we won't take. This grand total, this we won't take. Only this much. See. So what are all the observed values here? 18, 36, 21, 9, 6, 12, 36, 45, 36, 21, 6, 9, 9, 3, like that up to this. So these observed values we are writing here. See, in this table we have written all the observed values. The corresponding expected values, we got it from the previous table. See, here we have all the expected values. Corresponding expected values also got it from this table. So we got it as like, I have written 11.7, 27, 25.2. It will go like this. It's a lot of values are there. So I, have written all these values as well. So you can calculate observed minus expected. It is 6.3 here. 36 minus 27. It is 9 here. Like this, you can here also you can calculate here. So all the values you can calculate. Here you will get 3 and 3.3. Here you got a minus 0.3. So you will, after that you will calculate O minus E the whole square. So here you will square all the values. See, this is O minus E, the square of 6.3, this square of 9, 81, the square of this value here you will put, square of this value here you will put, square of this one, everything you will. Here a lot of values are there. I haven't included those values. So the here also the square of minus 0.3, it is 0.09. After that, again you will divide with the expected value. So this value, the corresponding expected value is 11.7. When you divide 39.69 with 11.7, you will get 3.39. Again 81, that is divided by the expected value, it is 27, you will get 3. Like this, here you will get O minus E the whole square, you will divide with this value, the corresponding values you will get. So all these values you will get. Here you understood the math is sigma of O minus E the whole square, the whole divided by E. See, we got the O minus E the whole square divided by E here. The sigma of all these things, the summation of all these things will be the chi-square. See, this 23.57 is the chi-square. That is the math. That is the mathematical formula. Summation of O minus E the whole square divided by E. So we got 23.57 as chi-square. After that, this is the calculated chi-square value is 23.57. This is the calculated value of chi-square is 23.57. Now the tabular value of chi-square and degree of freedom. We have the tabular value, we have to get it from the chi-square distribution table. See, I will tell you about the chi-square distribution. From that chi-square distribution table, we will get the tabular value. It is related to the degree of freedom. So in statistics, I am explaining you what is degree of freedom and the tabular value of chi-square. We got only the calculated chi-square value. Now I am going to tell you what is the tabular value of chi-square and the degree of freedom. First, I am telling you what is degree of freedom. Degree of freedom in statistics are the number of independent values that a statistical analysis can estimate. The formula for degree of freedom is column minus 1 into row minus 1. Here, number of columns here in your the first table, you can see here the number of columns. It is you can see it here. It is in our formula, it is written as it is 5 my 5, right? Number of columns, it is 5, and number of rows, it is 4. You can see it here. This is the see, number of columns, it is 1 2 3 4 5. Here 5 columns. And what is the number of rows here? 1 2 3 4, 4 rows. Even both in expected values and observed values also, it will be same, right? So this grand total we want take. See, in the data we have what is the number of rows here? It is 4 rows and 5 columns you have. So you understood that we use that formula for, that is the degree of freedom is column minus 1 into row minus 1, that is 5 minus 1 into 4 minus 1, that is 4 into 3, it is 12. 12 is the degree of freedom. Now I am explaining you the tabular value of chi-square. For that, you need to have the chi-square distribution table. See, you can get it from the net. This chi-square distribution table, it is, this is a unique table. It's, it's common. You can get the table from the net. So this table, I have, put it here. This is the chi-square distribution table. We need to calculate we need to find out the value of chi-square here. See, these values, these are all the degree of freedom. Whatever it is given here, this is the degree of freedom. What is these values it's given? Is this the significance level I told you in the beginning? Significance level. It is denoted by alpha. Significance level is denoted by alpha, and its most common value is 0.05 or 5%. There is separate video in the playlist statistics. You can watch it to get more clarity. This is really important. And the significance level alpha is 0.05 is the most common value. Then what is all these values? These are all the chi-square values. In the the data, the whole data, it is here. It is given as the chi-square value. So you got it. So we need to find out for a degree of freedom of 12 and for a significance level of 0.05, what is the chi-square? That is the tabular value of chi-square. That is the, correct value, that is the unique value of chi-square for this degree of freedom and for this significance level. So let me see from the table. So see, this is 12, degree of freedom, it is 12, and for 0.05, see, this is the value, 21.026. 0.05 for the significance level of 0.05 and degree of freedom 12. You have the chi-square value, the tabular value, it is it is 21.026. You got it. So the tabular value of chi-square value versus calculated value. See, the tabular value of chi-square, you got it as 21.03, and the chi-square, the calculated chi-square value is 23.57. that we got it from our calculations. So see, from here you got it 23.57 from our calculation of chi-square. You got the calculated value of chi-square. See here, the calculated chi-square is greater than the tabular chi-square, that is the critical value. The tabular chi-square is also known as the critical value of chi-square. Here the calculated value of chi-square is greater than the critical value of chi-square. So hence we reject the null hypothesis. We reject the null hypothesis and accept alternate hypothesis. If the calculated chi-square value is less than the tabular chi-square or critical value, we won't reject null hypothesis. Here, the calculated value of chi-square is greater than the tabular value of chi-square or critical value. So we reject the null hypothesis and accept the alternate hypothesis. What is alternate hypothesis? So we concluded there is a significant relationship between marital status and educational qualification. That's the conclusion we can make from this chi-square test. So we understood there is a significant relationship between marital status and the educational qualification. That is the result of the chi-square test. You understood. So these are all the pros of chi-square test. I am discussing the pros and cons of chi-square test. It is easier to compute. Pros, it can also be used with the nominal data. It does not assume anything about the data distribution. This is really important. There is no assumptions. And it's easy as well. So these things are all the pros of chi-square test. The cons of chi-square test, the number of observations should be more than 20. Data must be frequency data. It assumes random sampling. It means the sample should be selected randomly. It is sensitive to small frequencies, which leads to erroneous conclusions. It's also sensitive to sample size. These are all the cons of chi-square test. So when you when you select chi-square test for your data set, you need to understand these aspects as well. Thanks for watching. Please like, share, and subscribe. Thanks a lot.